This is a Jaguar, roughly 200 pounds of muscle and has the strongest bite force of any big cat alive today. And this is a Puma, smaller skull, longer legs, with a completely different hunting strategy. Both of them live in the Amazon, both of them are cats, and at first glance that seems completely normal. Like, of course they're cats, what else would they be? But here's where it gets interesting. Because if you zoom out, not just across the Amazon, but across the entire planet, you start to notice something genuinely strange. Evolution didn't just make jaguars and pumas, it made lions in Africa, tigers in Asia, leopards across both. Cheetahs, snow leopards, clouded leopards, roughly 40 species of true cats spread across every continent except Antarctica. And then completely separately, on different continents, from totally unrelated starting materials, it made animals that are not cats at all, but look exactly like them. We're talking about animals that evolved the cat design from scratch, millions of years before true cats even existed. Some of them aren't even placental mammals. So what is it about the cat body plan that makes evolution keep reaching for it? Why did nature independently invent this predator at least 5 separate times? And if the design is so perfect, why are so many of its versions now extinct? Let's start in the Amazon because that's where we are. 2 large cats, 1 jungle. The Jaguar is the heavyweight, stocky, powerful, built like a compressed tank. It is the only big cat on the planet that bites directly through its prey's skull rather than aiming for the neck. It doesn't chase prey over long distances, it ambushes from dense cover. Jaguars have the strongest bite force relative to body size of any big cat, roughly 1,500 pounds per square inch. For context, a lion bites at about 650. The Jaguar almost doubles that. The Puma, by contrast, is built like a distance athlete. Longer limbs, lighter frame, more explosive acceleration. Pumas will chase prey across broken terrain at speeds a Jaguar's body simply isn't designed for. Same forest, same basic cat template, 2 completely different athletic profiles carved out of the same blueprint. But here's the thing. These 2 cats represent just one branch of a much larger family tree, roughly 40 species across the planet. Different sizes, different habitats, different hunting styles, but all of them share a recognizable set of features that scream cat. Respectable claws that stay sharp, forward-facing eyes for binocular depth perception, a flexible spine that compresses and extends like a spring, and a short, broad face with powerful jaw muscles optimized for gripping, not chewing. That's the cat toolkit, and it works so well that felids have spread across nearly every terrestrial ecosystem on Earth. From the Siberian tiger at 600 pounds in sub-zero taiga to the black-footed cat at 5 pounds in the South African desert, the same basic design, scaled up and down, operating on the same mechanical principles. But this is where the story gets genuinely strange, because true cats are not the only animals that ever figured out this design. Roughly 40 million years ago, long before anything you'd recognize as a lion or a tiger existed, North America and Eurasia were prowled by a group of predators called the nimravidae. Paleontologists call them false saber-toothed cats. They had retractable claws, short powerful faces, and muscular low-slung bodies built for ambush hunting. They had elongated canine teeth, saber teeth, that were functionally identical to what Smilodon would evolve tens of millions of years later in actual cats. If you saw a nimravid reconstruction in a museum, you would assume it was a cat. You would be wrong. Nimravids are not cats. They split from the lineage that would eventually produce cats, dogs, bears, and weasels before any of those groups had really differentiated. They were their own thing, an independent evolutionary experiment that arrived at the cat design millions of years before true cats ever figured it out. And they were spectacularly successful, dominating large predator niches across the northern hemisphere for over 30 million years. Then, because evolution apparently doesn't learn its lesson the first time, a separate lineage called the Fragility did it again. Different family, different starting material, same result. Short face, retractable claws, ambush body, saber-teeth. They appeared after nimravids had already declined, as if the cat blueprint was just sitting there, waiting for someone to pick it back up. But neither of these is the weirdest example. The weirdest example comes from a continent where no placental carnivore, no cat, no dog, no bear, had ever set foot. Australia, for most of its evolutionary history, was a marsupial-only zone. Isolated for tens of millions of years, no placental predators whatsoever. And yet, when you dig into the Australian fossil record from the Pleistocene, not that long ago, geologically speaking, you find an animal called Thylacoleo carnifex, the marsupial lion. Thylacoleo had retractable claws, not cat claws. These were modified thumb claws, a completely different anatomical origin, but they retracted. It had forward-facing eyes for depth perception. It had powerful forelimbs built for grappling prey. It had specialized slicing cheek teeth that served the exact same function as a cat's carnassials, even though they evolved from completely different teeth in the jaw. It had a robust, muscular body and a short face. It was, to an almost comical degree, a cat made out of marsupial parts. And yes, this guy is completely real. The largest species weighed over 280 pounds. That's bigger than a fridge. It was the apex predator of Ice Age Australia, hunting giant kangaroos and diprotodons. Nature handed a continent with 0 cats, looked at the available materials, pouched mammals with no evolutionary connection to anything feline, and built a cat anyway. But even that's not the strangest part, because there's a living example of this phenomenon right now on the island of Madagascar. The Fossa is the largest native predator on Madagascar. It weighs about 20 pounds. It has a long, muscular body, a short face, semi-retractable claws, and a tail as long as its torso that it uses for balance while chasing lemurs through the canopy. If you look at a fossa, your brain immediately files it under cat. Your brain is wrong. The fossa is more closely related to a mongoose than it is to any feline. Its last common ancestor with cats lived over 50 million years ago. Madagascar, isolated for tens of millions of years, had no native cats whatsoever. So a mongoose relative, a small weasel-shaped insectivore, got pushed by natural selection into the large predator vacancy, and over evolutionary time, it reshaped itself into something that looks and hunts almost exactly like a small cougar. Evolution looked at an island with no cats, looked at the available predator niche, and said, fine, I'll make one. So why is it that evolution keeps building cats? What is so perfect about this design that it emerged independently at least 4 separate times in true felids, nimravids, barbarophilids, and marsupial lines, with the fossa as a 5th smaller scale rerun of the same idea? The answer is the hunting niche, ambushing medium to large prey in complex terrain. Forests, tall grass, broken ground is one of the most reliable ecological strategies on Earth. There's always going to be something to eat that's bigger and faster than you are in a straight line, which means the predator that can close distance undetected and deliver a killing strike before the prey can react will always have an advantage. And the physical requirements for that strategy are remarkably narrow. You need forward-facing eyes for depth perception, because you're judging pounds distance in 3 dimensions. You need retractable claws that stay sharp, because a dull claw doesn't grip. You need a flexible, spring-loaded spine because explosive acceleration from a dead stop is how ambush predators convert patience into momentum. You need a short, powerful face and specialized slicing teeth because once you've grabbed the prey, you need to kill it quickly. A drawn-out struggle in the undergrowth is a broken leg waiting to happen. And you need to be solitary because stalking requires silence and a pack makes noise. That's the cat design, and it's not an accident that it keeps re-emerging. The environmental problem, ambush hunting in structurally complex habitats, is so consistent across continents and across epochs that the solution keeps converging on the same set of answers. Compare this to dogs, wolves, jackals, African wild dogs. They run prey down over distance. They're built for endurance, for cooperation, for open terrain. That's a different solution to a different problem. The cat design wins in the forest. The dog design wins on the plain. Different niches, different blueprints. But here's what makes the cat story so remarkable. The anteater design, which we covered in a previous video, solves one extremely narrow problem: extracting social insects from fortified nests. It's a hyper-specialist strategy. The cat design, by contrast, is a generalist predator strategy that scales remarkably well across body sizes. A 5-pound black-footed cat in South Africa and a 500-pound Siberian tiger are using essentially the same toolkit, the same ambush stalk pound sequence, the same claw and spine mechanics, just at wildly different scales. The cat body plan is not just convergent, it's scalable. And that's why it's everywhere. But if the cat design is so effective, where are the nimravids now? Where's Thylacoleo? Where's the Barbarophilidae? All extinct. And this is the uncomfortable flip side. The same features that make cats such effective ambush predators also make them brittle when conditions change. Solitary hunters need large territories. Large territories require intact connected habitats, and the specialized prey capture toolkit, the short face, the slicing teeth, the explosive but unsustainable sprint speed means cats cannot easily switch to a different hunting strategy if their preferred prey disappears. A coyote can scavenge, hunt small game, eat fruit, switch to garbage, and cooperate with a pack when conditions demand it. A jaguar cannot. The specialization that made it perfect for one strategy makes it vulnerable when that strategy stops working. And right now in the Amazon, that's exactly what's happening. Jaguar populations are declining across their range, not because there's anything wrong with the jaguar design, but because the forest itself is being carved into fragments too small to support a solitary apex predator with a 50 square mile territory. Pumas are slightly more resilient. They're more generalist, more adaptable, but they're still losing ground. And globally, of the roughly 40 species in the cat family, almost all of them are in decline. Lions down 43% in 2 decades. Tigers restricted to 7% of their historic range. Cheetahs down to fewer than 7,000 adults. The Fossa on Madagascar, that mongoose that evolution bent into a cat over 50 million years, is classified as vulnerable. Fewer than 2,500 adults remain. Madagascar's forests are shrinking. The Fossa's accidental journey toward felinity may end in our lifetime. Evolution spent 40 million years perfecting this predator, reinventing it again and again across different continents and different starting materials. And in the span of a few human generations, we're watching most of its versions slip toward extinction at the same time. But here's the weirdest part. Even as the living versions decline, the design itself is so deeply embedded in how evolution solves the ambush predator problem that it will almost certainly re-emerge again. Maybe not in our lifetime, maybe not even in our species' lifetime, but somewhere on Earth at some point in the future, an ecosystem with dense cover, abundant prey, and no efficient ambush specialist will exist And whatever flexible mammal lineage is available will start getting pushed slowly, incrementally, toward the same solution. Flood an ecosystem with prey, fill it with dense cover, and wait. Evolution will build a cat. Thanks for watching, everybody. Remember to subscribe and hit the like button. I appreciate you all very much. If you enjoyed this video, be sure to check out this one here.